Good morning, good afternoon, and good evening, everybody. So we'll start. I'm Chhatrapati. I'm in this industry for about 2 decades now. I've been working on different communication standards and industry-related specific topics. I've been part of 𝐓𝐻𝐶𝐞𝐨𝐫𝐲𝐬 for about 8 years now, primarily working on different industrial communication protocols and standards, representing 𝐓𝐻𝐶𝐞𝐨𝐫𝐲𝐬 at different industrial organizations, including OPC Foundation. And I'm also author of a book on OPC, especially defining and describing for the people who wants to understand how OPC can benefit if they adopt in their organization. Yeah, that's about me. And today's webinar is about how do we implement OPC UA FX in a controller. So if you are looking at adopting OPC UA FX, and if you want to implement OPC UA FX capabilities into the controller, then what are the different aspects that we need to look at, and how do we implement it? So that's what we're going to cover today. This webinar is part of a series of webinars. So this is part 4, and all the previous parts you can find in our LinkedIn group, OPC UA FX Professionals. In case you haven't joined yet, you can join this group where we share knowledge on OPC UA FX and related technologies. This is a combined effort from different organizations, including Beyond Automation, Schneider Electric, BE Services, 𝐓𝐻𝐶𝐞𝐨𝐫𝐲𝐬, and so on. So you can find a lot of interesting articles and webinars on this group. So yeah, we will get into the topic. So just to give an overview of OPC FX. So OPC FX is basically a set of extensions to existing OPC UA specification. So it enables devices, controllers, and different computing applications to have secured, interoperable, and scalable information exchange. These extensions define different aspects of automation applications, like component models, application profiles, communication models, and configurations, and engineering aspects, and so on. So this is an architecture which is specifically designed for field level communications and industrial automation. And here you can see all the different extensions that are specific to OPC UA FX and the existing OPC UA technologies as well. So it depends on other standardized technologies like TSN and other standardized and commoditized security technologies, and so on. So this is a very high-level communication model that happens within the OPC UA FX standards. So there are different communication channels that are possible here. So compute to compute, compute to controller, controller to device, device to compute, and device to device, and the most important, controller to controller communication. So there are different use cases for each of these communications. For example, for controller to compute, uh, different dashboard applications and predictive maintenance analysis, and any energy optimization and monitoring and emission prediction applications can consume data that is being received from controllers. And the most important use case is related to controller communication. So it increases, or it provides interoperability between different machines to exchange data seamlessly in real time, independent of which controller belongs to which vendor and how it is implemented. So these are the topics which we usually begin with, in case if anybody are joining for the first time in this series, so that they get an overview of OPC UA FX. So looking at controllers, there are different types of controllers, fixed PLCs, modular PLCs, soft PLCs, and controllers which are part of distributed control systems, and then packs as well. So fixed PLCs are like very compact. They would have power supply, some fixed IOs with already integrated, and then they're used for very specific applications which are done in a closed loop. And then these are also known as like compact PLCs or integrated PLCs. So these are the most simplest forms of PLCs. And then the modular PLCs, they come with different modules to be attached to the CPU itself. Can be a module, and then the power supply, different IOs. So all these can be added or removed in a very flexible way. These are very highly scalable and flexible modules. They are suitable for very large and complex applications as well. And then the soft PLCs, so they're basically PLC programs running in a software environment, implemented in a software and running on a PC or some general purpose computers. So the reliability depends on the specific hardware on which they are running, since it's a general purpose PC. And these are useful for some less time critical and less data demanding applications. And then distributed controllers. So this is the very complex distributed control systems consist of several different controllers running in different locations of the plant, and then each of these controllers are responsible for a specific process or specific subsystem within the overall architecture, and this avoids any single point of failure. If any specific controller gets into a problem, only that specific process or subsystem is what needs to be troubleshooted and restarted. and of course, they already have a very high level of redundancy and other capabilities to avoid such situations as well. And the EPACs are kind of a combination between PCs and PLCs. What they are capable of is to process large amounts of data. They generally have large data processing capabilities. They can store large volumes of data. So this type of controllers are ideal for different applications that require extensive data logging, analysis, and reporting, and so on. So just a typical scenario on how a specific controller is used in the industrial automation setting. So here you can see two controllers, each controller controlling different devices, and we have an engineering station where these controllers are programmed, and then the configuration data is pushed into the controllers, and the controllers will take care of the rest by running these programs and controlling the devices. So when OPC UA FX is adopted, the overall data flow changes a little bit. Here, the engineering station will also have an additional functionality of a connection manager. So the connection manager is the term which is used in the OPC UA FX specification to describe the component which initiates and establishes connection between two automation components. And of course, the automation component is again a term within OPC UA FX specification. So it can be used to represent a specific automation component within an industrial automation system. So it can be a specific process within a controller, or a specific subroutine or functional block within a controller which is responsible for it. But for the purpose of this discussion, you can consider the entire controller as a single automation component. So here, the connection manager creates the connections between these controllers, and then initiates these connections by calling specific services of OPC UA FX. And then based on the pre-configured connection information, these controllers will start exchanging the data over PubSub directly with each other. So this enables a interoperable and seamless controller-to-controller data exchange, especially deterministic data exchange. So here again, the controller to device specification is still in the processing, but for the controller to controller communication, the specification is already released, and there are several prototypes and devices that are already available supporting this technology. So looking at high-level hardware architecture of a controller, of course, there are a lot of different variations to this architecture because every controller implementation is different based on the specific type of applications that they are targeting, specific type of communication interfaces that their end customers and end applications require. And in terms of costing, processing capabilities, and the whether it should have fixed IOs or flexible IOs. If it is a modular, then what is the expansion interface or whatever the back plane communication that should be there. So from all these aspects, the overall architecture completely varies from product to product, implementation to implementation. So we are not going to actually look into how do you design and implement an industrial controller. However, we are going to focus on how you can adapt OPC UA FX, and if you want to implement OPC UA FX capability in your controller, what are the specific parts and components that you should focus on. From that perspective, we will look at this hardware architecture. So when we do that, these are the parts that gets highlighted with respect to implementing OPC UA. So the processor and memory and the trusted platform module and network interfaces. At first glance, you can see that these are all very generic hardware components. This can be, you don't see anything specific or anything customized here. So a lot of the hardware platforms already have these components, and any of your existing controllers may already have these components as well. But that is the main benefit of OPC UA FX as well. It doesn't require any customized hardware for it to run. It simply defines that, okay, these are the technologies that should be supported, and all of those technologies are standards based, and they have been already part of different hardware platforms that are already available, and so on. So if we look at these hardware components that got highlighted for supporting OPC UA FX, first one is processor. Again, it varies depending on different types of applications and for exactly what kind of application or domain you're building your controller, and then what kind of processing powers, what kind of data exchange is required, what are the performance requirements in terms of different number of connections, and then the data that needs to be exchanged on each of these connections, and the rate at which the data needs to be exchanged. So depending on all these aspects, the requirements for a processor varies. And of course, here again, we're not talking about the execution of the control application itself and all the requirements that are required for that as well, and for maintaining the configuration and maintaining the IOs and the variable maps and so on. So any dual core with each core at least with 1 gigahertz, and then any it can be ARM or x86 platforms. So there are several hardware options from leading vendors that fit this configuration, or more based on exactly what is suitable for your application. So if you are looking at developing a a standalone communication module for your existing platform, then the overall requirements may be less. But if you are looking at upgrading your existing controller to perform more and then to add OPC FX capabilities, then it may look different as well. So just for explaining these considerations, I have put these items here. And then memory as well. So this again varies. So you can have 1 to 2 GB runtime memory, and then 4 GB of storage for OS stack and for storing the configuration data and other things. So here also several memory components are available from all the leading vendors. And the TPM. So this is the trusted platform module, and many features of this TPM can be leveraged by OPC UA FX implementations when you integrate it correctly, and when you pick a TPM with suitable features implemented in it. And again, this is again nothing. The TPMs are very generic. Nothing specific to OPC FX is required. This is an open standard. So the latest version is TPM version 2.0. So you should look for components that support or that has been certified to 2.0 version. And you should look at different crypto capabilities. What are all the different crypto algorithms that are supported, and what kind of key management features are there, and if they can do the encryption and decryption on themselves as a co-processor to the actual processor, taking much of the encryption and decryption loads of the main processor and perform. So from this aspect, you can look at the performance metrics of the TPM in terms of throughput, how much data it can encrypt per second, and so on. And then power consumption, what is the power rating, and does it meet your overall energy goals for the product? Does it help you to get there? So from that aspect as well. And any other special security features that are vendor specific and offering specific from these vendors. So there are several options available from Infineon, STMicro, Intel, Microchip, and other leading vendors in TPM. In some cases, they are integrated on the platforms itself that you may be choosing. So network interfaces, again, having multiple Ethernet ports has become a norm nowadays. So having multiple ports with 100 Mbps, 1 Gbps or higher. So this will help you from scalability perspective in long term, depending on how much data your overall hardware can actually process and exchange. And the Ethernet interfaces should have TSN capabilities, and the specific TSN capabilities that the OPC UA FX specification leverages on are listed here. So having a dedicated clock for IEEE 1588 integrated as part of the MAC, and then having the timing and synchronization capabilities and time-aware shaper, and as well as uh, frame preemption capabilities can be leveraged when you use OPC FX implementation on top of it. So, and you should also look for redundancy support. This is in terms of HSR or PRP based on the kind of applications that you are going to support. There are several components which are integrated switches with 3 ports or 6 ports. Components are available from leading vendors with TSN capabilities and integrated IEEE 1588 clocks, and then supporting all the TSN related capabilities with drivers supporting different operating systems and development platforms. So having such an integrated switch makes it easy to adopt all these network interface requirements. And if you are developing a controller for any specific hazardous environmental applications, then you should consider having an Ethernet APL interface. So Ethernet APL is advanced physical layer, which is meant for hazardous environment applications. It works on a 2-wire based interface, supports 10 Mbps. So here you'll not be running any time critical applications like some motion control or anything like that. These are mainly meant for process industries. And then the physical ports and the specific components, electrical specifications, and all, you should look for specific environmental robustness based on the application and the deployment environment of your hardware and so on. So by looking at all these different hardware considerations, it is clear that there is nothing specific that needs to be done in hardware. None of these hardware components are a specialty built for OPC UA FX. They are standard components which are available for any kind of TSN based or deterministic data exchange applications to run. So you can pick them up. And then there are several common hardware platforms which may support all of these requirements or most of these requirements. So the processor, memory, and everything combined as a common hardware platform are available from different leading vendors. And your existing hardware also may be compatible with all these requirements with minimal changes, and adopting these components considering these factors will make your product proof as well, future proof. And since these are all standard based and familiar hardware components and familiar approaches, so the development process itself is familiar. It is not some specialty built hardware where you need to where you or the development team needs to go through a learning curve from the hardware design perspective. So from the software architecture perspective, at high level, it has these components. So there's a connection manager running on the PC here. This gives the configuration data, and the controller application itself, which sits on top of an OPC UA stack, and there could be other PTP related stacks that executes the time synchronization routines, and then the address space itself based on the OPC UA FX information model, and then any companion specific information model which are standardized for domain specific applications. And then the Ethernet ports with supporting TSN MAC. So these are the main components of the software part here. And so the application or even OPC UA stack and then the PTP stack interact with the TSN clock data as well, and then the IO data and other data, and as well as configuration data related to TSN is exchanged between the stacks and the TSN MACs, and as well as connection manager communicates with the configuration data and application to establish connections and so on. So here again, looking at each of these software components, for each one, what are the different options available and what are the considerations that needs to take when choosing these components. We will look at that. So of course the first and most important aspect is OPC UA stacks. So we have some open source stacks and also some commercially available stacks as well. So looking at open source stacks, so we have a few of them here. So Open62541, even though this is an open source stack, it is the project management of this stack development and feature additions and maintenance is done by Fraunhofer Institute and OSADL with support from other industrial companies. So as of now, it already have PubSub support, and as well as all the OPC UA related security facets are all supported, and it is written in ANSI. So it can be further extended to support all the OPC UA FX related information models and methods and necessary extensions on top of it. And then there is this S2 OPC stack. This is a little bit specialty stack because it focuses on safety and security. It has been already ported and tested on different platforms, meaning different hardware and OS combinations. It supports PubSub as well. And with a clear intent to adopt OPC UA FX and implement OPC UA FX, they have already been working on integrating TSN support into it. So I hope sometime soon they will have the OPC UA FX related extensions as well built on top of it. However, the stack in its current stage, you can actually take it and implement the OPC UA FX information model and necessary methods to implement your own OPC UA FX controller and other functionalities related to it. It is written in C. And then there is another stack. This is the status of this is currently unclear in the public. So this is a project initiated by companies AWS, Unlock Devices, B&R, Schneider Electric, Lattice, and Texas Instruments, with the intention of providing an open OPC over TSN with free RTOS combined as a package, so that it can be utilized by anybody who's looking to implement a free RTOS based controller or device or any application with OPC UA, and extending this to support OPC UA FX is also is possible and very easily doable. And as far as I know, as part of some of the efforts that are going on in the OPC FX prototyping working group, the Open 62541 has already been extended and implemented with OPC FX functionalities by some of the members. So it is quite possible to pick any of these stacks and implement OPC FX on top of it. So these are some of the commercially available stacks. So Unified Automation, a very active member in the OPC UA Foundation, and as well as OPC FX specification working groups and prototyping working groups. They already have a stack which supports the OPC FX information models and as well as features. So PubSub and security integration have been already there, and it is available in C, C++, .NET, and high performance stack variants. So the C, C++, and high performance stack variants already have OPC AFX with them. And there are some reference implementations as well, and some products as well with these stacks running on them. And Flex SDK is an SDK from Maticon. It supports PubSub and security. It has it's implemented in C++. This SDK also can be very easily extended to OPC FX. So there is this ETSN stack available from BE services. They are also part of this initiative, and they'll be conducting the next webinar in this series. So we'll talk about it a little later. So what they have done is they have built all the other supporting drivers and layers on top of the Flex SDK. So these additional layers will leverage all the different TSN related capabilities of hardware, also with all these extensions, and also different OPC FX application profiles like motion profile and IOs and so on. So it has been ported and tested on different platforms, hardware and OS platforms, and they have a clearly published roadmap which they have been following and meeting as per the roadmap in terms of adding new features and adding new interfaces, which will make the overall product development much easy when somebody takes this up and uses it to build OPC FX based products. And additionally, it has a flexibility for you to choose your own OPC SDK and integrate it as well. So it comes with the 𝐸FLEX SDK already integrated, but you can also choose to integrate a different OPC UA SDK and still leverage all these additional interfaces and drivers and packages that are implemented for making it easy for any OPC UA FX product development. So in addition to the stack, we need these other aspects as well. So operating system considerations. So any RTOS would be suitable if you are looking at implementing a very deterministic and reliable communication capabilities into your controller. So VxWorks, QNX, FreeRTOS, Zephyr, in time, RTLNX. These are some of the ones that are available, and there are already OPC UA and as well as OPC UA FX implementations ported and executed and being tested on these platforms in some of the prototypes. That's why I have listed these. So like again, the OPC UA FX technology itself doesn't force you to choose a specific operating system. It is quite open and based on your preference and whatever you are comfortable with, or whatever your product line has been already using it, you can pick and use it. And related to time synchronization, there are different stacks that are available. Again, there is a time synchronization related stack available as part of the 𝐸TSN package as well, and different PTP and GPTP related stacks are available from different vendors. So and for the so whenever you develop and design and develop a controller, it's only natural for you to provide the software to configure the controller, and then program it, and then create necessary connections between multiple controllers and so on. So with OPC UA FX, the establishing connection and configuration responsibility falls on the connection manager. Your existing applications and interfaces related to doing the control program and then downloading the control program and executing it, all of that will be there as is. This only is an additional component that takes care of connection establishment and connection maintenance. So here you need to look for if the stack already has, so any specific stack when you are picking up, whether the stack already has some support to design and build a connection manager component into your existing software very easily, and which stack supports the programming language or model with which you can very easily integrate it with your existing configuration applications or programming applications that you provide with along with your controllers and other products. And the OPC UA FX configuration parameters itself for these connections are a little complex. So when you are designing the UI and UX for configuration or creation of these connections and configurations, you need to consider how you can simplify this in a manner where it is very much easy to use for the end users, but still have an additional advanced settings or advanced configuration methods with which they'll have uh, very precise control over the connections. But for most of the common use cases with a simplified connection configuration, you should be able to achieve the controller to controller communication. And uh, this connection manager component itself can be embedded into your controllers, and that will allow you to scale the entire system in a very easy manner. So a controller can work as a connection manager between um, two other controllers, or itself and other controllers, and so on. So this will allow you to scale the overall system when you have this feature also as part of your controllers. So in addition to whatever we have looked at so far, there are a few other considerations. So platforms. So instead of looking at uh, each of these components separately and trying to build a platform or a specific hardware, you can look at readily available platforms, which are hardware and as well as OS, and some of the drivers already ported and very easy to uh, use and start the development process. So you can look at when you're looking at such platforms, you look for all the different hardware capabilities from the perspective of the requirements and considerations that we have discussed today, and also the RTOS and real-time capabilities of the platform, and what are all the supporting technology stacks that are already ported and proven on these platforms, like TSN drivers or PTP or GPTP stacks, and so on, and scalability uh, in terms of whether the application itself or the component itself can be scaled to increase more connections or add additional uh, interfaces to gather the data, or provide any additional application level profiles that may be added into the OPC UA FX specification into the in the future. So considering all these aspects, uh, you can look at platforms. And when you are looking at vendors from which you are procuring some of the software components, or even hardware components for that matter, so you can look at some of these aspects. So whether they are OPC Foundation members, are they actively participating in working groups so that they are up to date on the development of any new features and optimizations, and any security related aspects that are being developed and added to the specification, and do they keep all of their offerings maintained as per the developments that are happening on the specification side, as and when new versions are released, how quickly they're able to uh, release their offering with an update, especially related to security and any performance enhancements, or any new application profiles that may be useful for your end users. And from the project execution perspective, and maintaining or assuring interoperability, perspective, you can look at some of these aspects. So become a member of OPC Foundation, and consider participating in the prototyping working groups, where you will understand any practical challenges uh, that are being faced by others who are trying to implement OPC UA FX into their controllers, and at what stage they are there, and what kind of challenges they are facing. And it will also give you better understanding of all the different components and other software components and stacks and other things that are available in the overall ecosystem. And the working group conducts IOPs. These are interoperability plug fests. So consider attending them during your development process, so that you can see how your controller interoperably operates along with other controllers, other connection manager applications, and so on. So that will give you the chance to understand any implementation specific issues that may cause an interoperability issue later when it goes to the field and your end user. And also, this whole group works on a specific demo application as a base, and everybody has that as a demo application, example application, with which all these interoperabilities and everything is tested. And based on that, there's a demo wall that is created by OPC Foundation. And once your implementation reaches certain level, you can consider participating in that demo wall as well. Already a lot of member companies have their implementations in the demo wall, where a live demo of OPC FX is demonstrated to all the visitors in different trade shows and other seminars and other events. So here again, the demo wall consists of different companies, from network component vendors to controller vendors and other software providers and so on. So based on the specific implementation that you have, you can choose to be part of this as well. So with this, we reach to end of today's session. So there's an upcoming session of the same series of webinar. It's scheduled on 13th February, achieving real-time Ethernet performance using UAFX. So this is being presented by Melvin Francis from BE Services. So he'll present it. And we also have further webinars scheduled every 2 weeks once going forward. And we will publish the dates and then the specific topics for these webinars as well. We are getting a lot of interest from other member companies who are interested in sharing their knowledge related to OPC FX in this forum. So the upcoming webinars with Belden and Intel are already in discussions, and we will let you know once they are finalized on the dates and then the topics and the timings and so on. So keep following our LinkedIn group page, and you'll get this information on that page as well. So thank you for joining, and in case if you have any questions, please leave them in the comment section, and I will try to answer them for you. And all these questions and answers we will publish on the OPC UA FX Professionals LinkedIn group. Thank you.